Hi everyone, welcome to Code Kamkar's YouTube channel. I hope everybody are doing good. In the last videos, we had seen and we had discussed about MLOps, MLOps architecture, and we had seen how DevOps have um, applied on MLOps, and we had compared the architectural diagram, and we had seen what all stages that we have in machine learning development life cycle, and we had discussed each one of the stage in the last couple of videos. Today we'll see like a simple machine learning code by looking into all the stages that we have discussed in last video. So if you remember the last video we had discussed about all the stages like data preparation, exploratory data analysis and feature engineering and model selection, evaluation and testing and we had discussed about hyperparameter tuning and model deployment. So today we are going to take a sample code which is house prediction, and there we are going to call all the stages of machine learning development lifecycle, and we will see how each stage is going to helpful to bring a good prediction into a house, right? House rate predictions, and there we will take a sample raw data, like as a best practices, you might take some offline data from CSV file, or you can get the data from APIs or any other resources. Here we are for better understanding purpose, we are going to take some raw data. Sorry. So we're going to take some raw data, and with the raw data, we're going to call the model, and we're going to visualize the data with the different aspects and x and y axes, and we are going to see how the data is being visualized, and we're going to clean the data like data pre-processing, and we'll discuss what all modules and what all libraries that we are going to use in this entire simple machine learning. So I'm going to show you the source code of this entire, simple machine learning model, and I'll post this code into GitHub repository. You can go and refer my GitHub repository for better understandable, and you can play around with this data. So we have a bunch of stages into entire this, source code. Like we have a bunch of stages. We have discussed about each stage. So I would like to show you how code looks like on each stage and how each stage can helpful to other stage to bring the better predictions. So like as we discussed, so we are going to discuss about house predictions, like house price predictions. To do this activity, we need to import few libraries. Like we have pandas and we have sklearn and we have matplotlib and seaborn. So pandas is like these all are all the libraries are of Python, and you can see what kind of version you would like to use for each library. So it's up to you which version you would like to use. So I've been using all the latest versions here. And if I discuss each one of the library, pandas can use for data manipulation and sklearn. So it's going to it's going to use for implementing the machine learning algorithms like more effectively and efficiently. And matplotlib, we are going to, it can be used for visualization. We can use matplotlib for creating graphical way, and we can use different kinds of graphical ways to visualize the data for better understandability. And another library we have, that's one is Seaborn. So Seaborn is can use for statistical visualization, like taking x and y axis, and by using the data, you can look into the statistical visualization for better understanding how your data has been looking into by applying different operations. So that's fine. In the first stage, we have discussed about importing libraries in the sample machine learning model. And the second one is loading data. So here I'm going to take some raw data. Um, in our case, you might have seen in different blocks or different resources, they might take some offline data. So I don't want to make any complicate on this machine learning model and to predict house prices. So that's why I have taken some raw data in my source code itself. I have taken size, bedrooms, age, and price. So we have a size of 1,500, 1,600, and 1,700 square feet. and bedrooms like three bedrooms, two bed and four bedrooms. And age is 10 years, 20 years, and all. And the price is like we have 3 lakhs and 3 lakh 2,000. Different values we have based on the size and bedrooms and age. So we have all these components, and this component has to be equal. Like we have the size of one, two, three, 4, and 5. The similarly, it has to match with all the parameters that we have taken in data. And later we are going to take a data frame, like data frame as a pandas here, and we are going to take the data frame and we are keeping it as a data frame variable is data. And later we are going to, for better understandability, so what we are doing, so we are going to display the statistical way, and I'll show you like how this data will be visualized into relationship and statistical once I run this source code. So now loading data, which means like here we're just loading up the data. First we are taking the data frame, and later we are going to call the exploratory data analysis. So in that we are going to see how the data looks like by applying a statistical visualization and passing the particular variable, and we are going to look into the visualization over there by specifying the data frame, and we'll see how the relationship is going to be based on the size, bedroom, age, and price. So we are going to see how this all relationship can be mapped each other based on the values that we have taken into data. So we have discussed about loading the data, which we have done over here. Like we have taken the data, and we have taken as data frame, and the data frame we are using a statistical discipline, which is called as a exploratory data analysis. So here, in a regularly, what you can do, you can take the data. You can see how data is matching as per your requirement, and you can understand what kind of data you would like to take. So there are different aspects, like we have already discussed about exploratory data analysis in last video. And next one is data processing. So, like here we are going to specify what kind of features you are going to take and what is the target variable, like size, bedroom, and age, and price. So, we are going to take X and Y, axis. So, you are going to take what on features that I would like to use for predicting the house values on specific parameters. So, here you are going to take the parameters in X axis, which is size, bedroom, and age, and Y data from you are taking as price. So now you're splitting the data and you are training into testing sets. So if you see here, we have X train and X test and Y train and Y test. So this is how we can train our data based on the accessible. And if you see here, we are going to train the test splits by specifying X and Y's, and test size is zero point 0.2 and random state is 42. So we're going to pass to component which is test size and the random test state. So by passing those things, so we can look into that data set, how it will look like on each axis. So that's the data pre-processing into considering the x and y axis and x train and y train. And second one is model building. So whatever data you have trained over here, you have done the data pre-processing. So what you are going to do, you are going to inject the data into the particular machine learning model. So for predicting the house prices, so here we are going to use the linear regression in the model, and we are appending it into the model variable here, and we are initializing the data into this particular model. If you see here, we are going to pass model.fit. We are going to inject the data over here, and here the data is xtrain and ytrain. So as you see here, xtrain and ytrain, we have taken it and we are injecting the data into model. So this is what we call as a model building. So once you done the model building, you need to test how your model is giving the predictions by test data. So that's why what you are doing. You're doing the model evaluation, which means like in a model testing with the data that you have present that you're having with you. So here we're going to specify the white rate and MFC, and you're going to specify mean square errors especially, which means like how your data is giving output values as actual and the predicted values in the mean square errors. So you're going to pass those mean square error here with the test data and the production values over here, and accordingly you're going to print those values as per your requirement. So this is how you can see that, like displaying the model coefficients. So you can look at how the model coefficients is looking into like actual value and the prediction value by specifying the mean squared errors. And the next stage is like visualizing the results. So here you're going to specify, you're going to visualize the data. Like you're going to plot our diagram here, like scatter diagram, and you can specify the labels over here, and you can give a title for this, like actual prices and production prices of your entire model. and you can show the entire data over here by plotting the schematic diagram. So this is how you can use all these stages. Like we have discussed about like importing the libraries and loading the data and exploring data analysis, and later we have the data pre-processing and model building, which means like we have taken some linear regression and we have built, we have injected the data that we have taken or opened there with the data frame, and we have discussed about like how we can test the model with the predicted and actual values, and like finally we can visualize the data as per the requirement. So this is a simple, very simple machine learning model, like to predict the house prices, and by taking the raw data into source code itself. And if I run this code, you will see like we will see two visualization. Like one is like visualizing the data relationship. This is the first one, and later you can see like the actual prediction values from here. Like this is the actual predictions and the predicted values. So let me run this code and we'll see a schematic diagram, and we'll see in the console itself, like how does it look like. The console values will print over here. If you see here, we have the count, which is we have taken as a size. Let me minimize this. So we have taken a size, bedroom, age, and prices. So this is how we have a count, mean, and stud main, 25, 50, 75, and the max. So these all values that we have taken as per the above data frame, and this is how it is giving the values over here. And this is the price as per the consideration of all the parameters, which as the count and mean, and as the right side we can see size of and bedroom size and age, and this is the price it is going to be priced over here. So if I go to visualization, so first we have discussed like first we are going to visualize the data which is related to the relationship of the data. If you see here, we are going to see like what is the relationship of data. So that's why we have print that schematic diagram. We have plotted the schematic diagram. If you see here in the left hand side, like we have taken the price and we have taken the age and bedroom. So this is how we can you can relate the data. You can look into that what all features they have, and how the data looks like by adding all the features, and you can explore more into that, and how the current data has been behaving before applying all the machine learning best practices on it. And you can get to know like what all features you would like to pick and what all features you would like to add. I can do that feature engineering stage, which means like exploratory data analysis. So this is the about the relationship data. Like you can consider about bedrooms count and age and price, and you can mark the data visualized over here. So if I close this, and it will be open another visualization diagram, a schematic diagram, which means like it is going to predict the actual versus predicted values prices. If you see this, like it is going to match as accurately. So this one, like we have the price over here, and right on the right side we have the actual price, and the which means like in the actual price we have the on the right side, and the predictor value this side. So here you can see an x and value, x and y axis. You can see that like how the actual price is matching with the predicted price by applying the this one the linear regression, and we have trained the model with the data that we presented, and we have evaluated at the end. And by evaluation you can see that like we are going to print the values over here, which is actual and versus predicted value. And if you see that in an x label, like here we have the x-axis we have the actual price, in a x-axis we have the actual price, and the y-axis we have the prediction price, which is accurately matching, which means like our machine learning model has been giving very accurate value. And this is how we can use the machine learning algorithms to predict the house prices by taking the offline data or raw data. You can do the automate in your source code itself. So for just for since it is a very initial stage that we are going to discuss about machine learning and machine learning algorithms and machine learning operations, that's why I brought very simple machine learning model. And in a future upcoming session, we will discuss about all the advanced concept, like what all machine learning types we have, and we have machine learning algorithms over there, and discuss each one of them, and theoretically and practically. And we'll jump into different machine learning tools for deploying the machine learning model very securely into the deployment into production. So Yeah, like we have discussed as per the topic to be covered, and that's all for this lecture. The next video we'll see and we'll discuss about what all machine learning best practices and modules and algorithms we have, and we'll come with the architectural diagrams, further videos, and we'll see, we'll complete this entire machine learning operation series. So until then, thank you for watching, and like this video and subscribe to the needed people who would like to are willing to learn the machine learning and machine learning operations. Until then, bye bye.